Hi, good morning, Mayank. It's good evening for you. And Amodita, can you change your name? So, in the last class, we were working on nomenclature. I've seen Mayank and Amodita, even Akash, he also did plenty of quizzes. So, you have any question from there? Okay, no questions. So, keep practicing nomenclature. It's very important to understand the subject. I think I told you that we are going to do the nomenclature of acids and bases. So, we did the polyatomic ions also, important polyatomic ions, Amodita. Can you type yes or no in the chat? And Mayank, may I request you to give messages only in journal chat? That is everyone, right? Okay, good. Okay, so we did the polyatomic ions. Now I'm going to teach you how to name an acid. So I'm taking you on the whiteboard to explain how to name acids and bases. Remember, there is one full unit, unit 8, unit 9. They are completely, unit 8 is completely based on acids and bases. Okay, so there are two types of acids, oxyacids. Oxyacids means oxygen containing acids. Oxygen, oxygen containing acids. And non-oxy acid. Non-oxy acid is without oxygen, without oxygen. This is very important. I have to teach you again maybe later on when we start with acids and bases again. So take it as very important concept. In oxygen containing acids, if your polyatomic ion is ending with 8, sulfate, nitrate, if they're ending with 8, then you will have the name as ic acid. Polyatomic ion ending with 8. If it is ending with ite, then it is us acid. I'll give you example of this. But if your polyatomic ion is, uh, sorry, not the polyatomic ion, if it is a non-oxy acid without oxygen, then the nomenclature is fixed. Hydro and then ic acid. It's fixed without oxygen. And what are acids? Acids are the compounds containing H plus. They are the compounds of H plus. For our level, for AP chemistry level, H plus. So can you tell me what is H plus? How many electrons are there in this H plus? How many protons? How many neutrons? Yes, I think I told you this earlier. Okay, good. H plus is a proton because it has 0 electron, 1 proton and 0 neutron. Yes, we have done this. This is a proton. It's very reactive species, is very small with intense positive charge. Is it electron rich or electron deficient? This this one is electron deficient. Very good. Okay. So now I'm giving you HBr. Can you name this acid? And give me 1 second. I'm back. Yes, hydrobromic acid. Perfect. Very good. Now name this HCl. HI, HI, H2S, H2S, hydrosulfuric acid. Can you name this? This CN is a polyatomic ion, but there is no oxygen. So it falls in the category of no, non-oxy acid, means without oxygen. So nomenclature will follow the same rule. So do you know what is CN minus? I have given you the polyatomic ion list. Check the name of this CN minus, cyanide. So what is the name of this acid? Name of this acid, Amodita? No, 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 no. Follow the same rule. Hydroic acid. Hydroic acid. So hydrocyanic acid. Yes, Akash, very good. Mayank, understood? So that's how you have to name your non-oxy acids. Now let's see how to name oxygen containing acids. You have your polyatomic acid list in front of you. Okay, so if it is 8, it will become ic if the polyatomic ion is. Mayank, where is your polyatomic ion list? I've given you last time, I told you to take out the printout. Akash, you have your polyatomic ion list with you? Okay. Mayank, I'm giving you again. So can you take out the printout? Okay, it's here. Okay. Name this acid. So search the polyatomic ion. In the list, search the polyatomic ion. And if it is ending with 8, just pick up that name and make it as ic acid. Yes, perchloric acid. Can you give me the formula of perbromic acid? Write the formula of perbromic acid. Perbromic. No, no, no. It's oxygen. Where is the oxygen, Amodita? Perbromic acid. Now, these are exactly same formulas. And when you are going to learn the Lewis dot structures, the shapes, and the polarity, we are going to learn so many things. Then you will see this chlorine and bromine. They are in the same family. Look at the periodic table. Halogens, chlorine, bromine, same family. So they have exactly same number of valence electrons. So their polyatomic ions are same. If you see, I've given the list of this chlorine, bromine, and iodine. Chlorine, bromine, and iodine together. Why? Because they are going to make same polyatomic ions, except fluorine. I think I told you the reason why fluorine is very different. Fluorine is different. Why? I'm not talking about fluorine because in fluorine, okay, Amodita, there is one more reason. Fluorine can gain only one electron. Fluorine cannot have more than one oxidation number, -1, because it is very electronegative and it can have only one more electron. Okay, you will learn that fluorine, oxygen, nitrogen are different from rest of the family because of the absence of d orbital. So we are going to learn that. Okay, can you give me the formula of hypoiodous acid? Hypoiodous acid. Formula. Yes. HIO. No, 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 Akash. HIO. IO minus is hypoiodide. And it will end with us. I told you here. If it is it will end with us. Acid. Okay, can you give me the formula of selenic acid? Selenic. So don't try to search it in the list. Do you know the formula of sulfate, children? Sulfate. Okay, Mayank, there is some error. Sulfate. What is sulfate? Check the polyatomic ion list. It is SO4 2 minus sulfate, right? So what is selenate? Sulfur and selenium are in the same family. Yes, Akash, you are right. Selenate is this, and Akash is right. Amodita, what you are writing is sulfur trioxide. Mayank, you can correct your formula. Can you give me the formula of tellurous acid? Tellurous. Same family, selenium, tellurium, check. Do you know the formula of sulfite? Sulfite. SO3 2 minus. So, Amodita, you are getting your error? No? Okay. This is sulfite. So, what is tellurite? They are in the same family. Give the formula of tellurite. Yes, Amodita. What's the formula of tellurite? Where is the charge? Take care of the charge. 2 minus. Now, how many hydrogens can come in front of this? How many H plus? 2. So, that's the formula. Yes, Akash. Good. Amudita, understood? Okay, good. Okay, so elements of the same family, except the first element. First element of every family, you can write down somewhere. This I will explain you again when we are going to do periodic trends. Elements of the first family, every first family is unique, is different from rest of the elements. It's just not because of the electronegativity. There are many differences. So Akash, can you just remove your, yeah, okay, no problem. So we have understood this, how to do the nomenclature of oxygen containing and without oxygen. Yes, Akash is asking what is a family. Yes, who is going to answer his question? Please answer questions of each other. So I'm sharing the periodic table. What's the meaning of the family, children? How many families are there? Yes, Akash. Period is the horizontal one, family is the vertical columns. Okay, good. So few more questions and then I'm starting the new topic. So you can practice this nomenclature. More you practice, more you learn. You can do the quizzes twice, thrice. If you feel that there is some question you are not understanding the answer, you can flag the question. You have seen the option of flagging the question. Okay, let me share my screen to make you understand how to flag the question. And you can put the question on the forum also. I think somebody, one of you have registered on the forum. Is it you, Amodita? Can you see my screen? Okay. Here is the quiz. One of the quiz done by Amodita. Can you change your name here also, Amodita? I want your real name here. Okay. Like, can you see the flag option here? Flag question. If you feel that your answer is right and my answer is wrong, then you can flag. Otherwise, with the help of snipping tool, you know a snipping tool, children? You can take a picture of the question like this and insert this image on the forum. Just give a title to the question and put it on the forum and submit it. It's not going to take much time. You have to come in practice in doing questions. See, only I'm teaching, you are learning. It's not sufficient. You can learn just by doing questions only. Okay, now you're listening and practicing. But the real learning is doing questions. More you do questions, more you ask questions from me, more better you will learn. That learning is just like, once you have learned how to do cycling, it's lifelong. Why? Because you are in practice of cycling. You stop practicing cycling, you will become slightly not very confident for cycling again. Like, I cannot cycle because I'm not cycling from last so many years. Okay, so practice is very, very important. So, ready, children, for the next topic? The next topic is very simple. Maybe you are already aware of it, but we are going to practice in detail, in depth. We'll do plenty of questions based on it. So, we are starting Unit 1. Till now, we were doing just the basic foundation. And today, we are starting Unit 1. And in Unit 1, we are starting with 1.1. The very first thing which we have to learn here is the meaning of Avogadro's number. Avogadro's number has a fixed value. It's called as Avogadro's number and it represents a mole. What does this represent? A mole. It's one mole. And what is mole, children? Mole is the SI unit of, it is the SI unit of amount. So please write down, mole is the SI unit of amount. If somebody asks you what is a mole, so what's the answer? Mole is a, yes children, what is mole? Mole is a number. Mole is a number, right? Sometime when I say that, okay, children, they know very well what is a mole. They are doing so many questions on the mole concept. But when I say what is a mole, what do you mean by a mole? Then they are not aware. So remember, what is a mole? It's just a number. Which number? Avogadro's number. Avogadro's number, is it a small number or big number? This one is a very big number. Like if I say, what is a dozen? Dozen is 12. If I say, what is a pair? Pair means 2. Right? Dozen means 12, pair means 2. Just like this. Pair 2, dozen 12. Mole means Avogadro's number. Is it okay? So understand the meaning of the mole. But this number is very big. Very, very big. Can you use this number on apples, pencils, ducks, like this? Can I use this number there? No. Can I count this number? No. So we cannot count this number. This number is very big. So without counting, how can I measure a number? How can I say, okay, this is the number in this given amount without counting? Any idea? We are going to do counting by weighing. Like for example, you want to take 5,000 jelly beans. You want to take 5,000. So, are you going to count them? No. What are you going to do? You are going to count. You are going to count 10, 5. Yes. But you have to count. How many? Whatever you can count. You can count 5. You can count 10. So let's say I counted 10 jelly beans. And then I'm going to weigh them. Let's say the weight is 11 grams. So 10 jelly beans are 11 grams. So what is the mass of 1? What is the mass of 1? 11 over 10. And this is what Akash is writing. See his language. He's saying it is the average weight. This is not exactly like if you pick up one jelly bean. So maybe it's not exactly 1.1 gram, right? But closer. It's the average weight. So 1.1 gram is the average weight of 1. So how much will be the weight of 5? How much will be the weight of 5,000? Yes. So what are you going to do? You will going to measure 5,500 grams of jelly beans, and that will be the 5,000 jelly beans in counting. Mayank, you're understanding this? Okay, good. So can I say that we can do counting by weighing? Exactly in the same way, Avogadro's number is very big. We are never going to count it. The reason is the same because number is so big, we need multiple lifetime to count it, right? See, this Avogadro number is a very, very big number. If you check in different books, if you're reading the books, then you will see that they are writing there. Like, even if all the people of Earth, they start counting it today, and everyone is counting one atom in 1 second, they say it will take 3 million years to count it, to get this number. So it's impossible to count. So what we are doing? This is the scientist, Avogadro. He has given us many important information. This number is really a magic number. Is represented by Na. He was an Italian scientist. Okay, so let's see how to count Avogadro's number by weighing. So I'm taking you on the periodic table again. So in the periodic table, I think in the very first class, I said that elements are represented by X and Z here and A here, right? This we have done. What is Z? If we have not done, understand this. Z is the atomic number, the nuclear charge, very good. Atomic number or nuclear charge. Why is saying it's the nuclear charge? Because Z is the number of protons inside the nucleus. And only protons have charge, neutrons have no charge. And A is the protons plus neutrons. This is also due to nucleus. A is also due to nucleus. Z is also due to nucleus, right? Okay, so if I take this sulfur, what is the atomic number of sulfur? And what is the mass number? It's not mass number, it's average atomic mass. What is it? If you take 32.06 grams, if you take this, then this represents 1 mole of sulfur. This is also called as molar mass of sulfur. So what is molar mass? Molar mass is mass of 1 mole of any element or compound. Yes. So Akash is telling us something else also. He's saying 32.06 gram is 1 mole of sulfur, which means the number of atoms are 6.022 times 10 raised to power 23. We are good with this? So can you give me the mass of atomic mass in grams? You have to take it in grams. So what is the atomic mass of silicon? Mass of 1 mole of silicon is 28.09 gram. Who is going to give me the unit of molar mass? Unit of molar mass is grams per mole. So please write it down. Some students are writing U. What is the full form of U, children? U is unified mass. So what is the mass of one atom of sulfur? One atom of sulfur. Yes, 32.06 U. What is the mass of one atom of silicon? 28.09 U. Very good. Very good. Okay, so it means the periodic table is giving you a great information. He's telling you the atomic masses in grams, which represents the molar mass, grams per mole. That if this much number of atoms are there, then the mass is this much. So here in the chemistry lab, we are never counting atoms. We cannot, because atoms are not visible. They are not visible, right? So you cannot count them. So what you are doing in the labs, always weighing. And then after weighing, you're converting those grams into moles. And moles can be converted into number of atoms. So most of the experiments are based on weighing. Okay. So we have to understand this concept, and we have to do plenty of questions on that. So periodic table is telling you the mass of 1 mole, and periodic table is also telling you the mass of one atom. The mass of one atom is always taken as U. U is a different unit. Gram is a different unit. So can we work out the relationship between U and gram? How the U unit, the unified mass, is related to gram? This is unified mass. How it is related to grams? Because you started telling me about U, so that's why I'm teaching you here. It will come in the presentation also. Don't worry. And you can download the PDFs from the website. Okay, so let's pick up oxygen. Can you give me the mass of 1 mole of oxygen? Oxygen atoms. Okay, let's take it 16.0 gram. 00 gram, right? Amodita, I'm taking 16.00 gram. Can you give me the mass of one atom of oxygen? One atom. 16.00 U. Now let's relate this gram and U. So can I say Avogadro's number of oxygen atom is 16.00 gram. Avogadro's number is 6.022 times 10 raised to power 23 atoms of oxygen. In U, what will be the mass? One atom is 16 U. This much number of atoms in U will be 16 times 6.022 times 10 raised to power 23 U. Can I say that? because 16U is the mass of one atom. But this is the mass of 1 mole of atoms. Akash, this Mayank. Mayank, you are with me? We are just doing mathematics. If you have any difficulty, you can ask question. So, can I say 16 times Avogadro's number, this number, U, which is the mass of 1 mole of atoms in U, is equal to 16.00 grams? This much? Okay, Mayank, why I cannot say that? Mayank, any questions? No, they are not equal, yes. But I'm getting the relationship between U and gram. Right now, dimension is same. This is the mass of 1 mole of oxygen atoms, which is in grams like this. In U, it is this. In grams, is this. So I can put them equal to each other. Yes, Amodita, very good. Amodita and Akash are using very good language. Perfect. So, Mayank, is it okay? We are checking the relationship, the ratio, relationship between U and gram. So, 16 and 16 cancelled. So, what is the relationship between U and gram? Avogadro's number of U is equal to 1 gram. Or 1 U, I'm just rearranging it. 1 U is equal to 1 gram divided by Avogadro's number. Yes, that's the relationship, Akash. Very good. Very perfect, Akash. So, Mayank, children understand Mayank is very young. So, we have to keep asking him whether he have understood because there is mathematics, so many things. So, thank you very much, Akash and Amodita. So, keep helping him. Mayank, it is clear? Mayank, are you there? So, and the best part is there will be no question based on it. Only thing is that you need to know U is a unified mass unit. So the elements which are here, if I take the mass in U, if I take this mass in U, then it represents one atom. If I take it in grams, it represents 1 mole of atoms. That's the only thing which you have to understand and practice. This relationship is never coming in the examination, but it's fun to know that how U and grams are related to each other. If you take Avogadro's number of U, then it becomes 1 gram, or 1 U is 1 divided by Avogadro's number of grams. Okay, now we are going back on the presentation. So we have understood the meaning of Avogadro's number, and then how this Avogadro's number, like this is a very defined number. It's a defined. So Avogadro's number is defined based on carbon element. So they said that in 12 grams, they did mathematics, they did experiments with the help of different experiments, and with mathematics, they proved that 12 grams of carbon has Avogadro's number of atoms. And you see in the periodic table, 12 gram is the molar mass of carbon, right? This is the molar mass. This is also equal to 1 mole of carbon. If I give you 24 grams of carbon atom and I want to know how many 24 grams of carbon and I want to know how many carbon atoms are there, then you can use the dimensional. 24 grams of carbon times This dimensional. What do you want? Number of atoms. So put your Avogadro's number here and 12 grams here. See, this is how you can do. The number is double of Avogadro's number. Can we do one question on it? Okay. Question is like this. There is 1.2044 times 10 raised to power 26 atoms of nitrogen. Convert this into grams of nitrogen. So you know that 1 mole of nitrogen is okay. Very good. Who has done this? Akash has already done it. You know this relationship, and you also know that 1 mole of nitrogen atom is Avogadro's number. So use this ratio. So let's see that whether Akash is right or wrong. He has placed the answer. Start with, again, I'm using some language which I want you to practice. Start with what is given to you. So I'm starting with 1 point. I'm going to set up a dimensional. Atoms of nitrogen. Plug in the first ratio. I'm going from atoms of nitrogen to moles of nitrogen because that's the ratio I know. That 1 mole of nitrogen is Avogadro's number. I can use this also. 14.01 gram of nitrogen divided by Avogadro's number. So what's the answer? And here your answer will be in atoms. Only Akash has given the answer. What about rest of you? This is 2, and when you cancel everything, you will get 200, right? Okay, you're also getting the same answer, Amodita. What about you, Mayank? You're getting the answer? Okay. So, and how many significant figures will be there in my answer? Significant figures will be decided. You have watched the videos of the significant figures? Significant figures will be decided from here. Oh no, Akash, you are not going to consider sig fig of the defined number. Please watch the video to become more expert in that. Okay, I have already uploaded the video. You are not going to consider any ratio. You're not going to consider any defined number. So you have to consider this number only. This number has 1, 2, 3, 4, 5. So your answer should have 5 significant figures. So you are giving me answer as 2802. This number has 4. So put a decimal and put 0. Now this is the right way. If there is a decimal, the trailing zeros are counted. These are trailing zeros. If there is a decimal, please watch that video and submit the quiz based on it. It's very important. This 0 is counted. It's a trailing 0 because there is a decimal is counted. Now this number has 5 sig fig. Menk? Okay. So ready for one more question? Okay, do this question. So what is given to you? Atoms of carbon. What do you know from the periodic table? That 1 mole of carbon is 12 grams. What is 10? Okay, that's the answer. Yes, Akash. Okay, so plug in the ratio. And you also know that 12 gram is Avogadro's number. So just plug in the ratio. Start with what is given to you. I'm teaching you dimensional also. Start with what is given to you and plug in this ratio. This one. Avogadro's number in the denominator, because we want to know the grams of carbon, and 12.00 grams of carbon here. And these are atoms of carbon. These are also atoms. And the answer is, how many significant figures? You're going to decide from this number. It's not a defined number, it's given number. So 4. And I think Amodita is giving me the right answer, 120.0 grams. Mayank, is it okay? And here, children, if you write 120, can you tell me, if I write 120, how many sigfigs here? How many sigfig here? Okay, the one who is writing 2 is correct. Mayank and Amodita, 0 is not counted. It's a trailing 0 and there is no decimal. A trailing means the 0 which is placed after the number. And if it is 120 point gram, then this 0 is counted. Now it is 3. One more question based on trailing zeros. 100.00. How many sigfig? 100. How many sigfig? You're understanding this? These are trailing zeros. Trailing zeros counted if there is a decimal. Trailing zeros not counted if there is no decimal. Okay, how many sigfig in this number? 0.0001. These are called as leading zeros. Leading zeros, Mayank, Amodita, you have not watched the video, okay? That's why you're wrong. They are never counted. Leading zeros never counted. Because now we have started doing mathematics. So I want you to watch that video. Leading zeros never counted. If I give you this number 0.000100, how many sigfig? How many sigfig? Which zeros are counted? These are counted because there is a decimal. These leading zeros never counted. Okay, so practice these rules. Okay, so we have already understood the relationship between your moles and U and gram also we have understood. Can we do one more question? Check this question. The mass is given. They're asking you to calculate the oxygen atoms. So you start with what is given. What is given? This is given. Start with that. 2.7 times 10 raised to power minus 23 grams. Plug in the ratio. Akash, is this the answer? Which ratio you are going to plug in? They're asking the number of atoms. So you know that Avogadro's number is 16.00 gram. So plug in this ratio. Oh, okay. This is the mass of one atom. Okay, okay. They are asking you to calculate the mass of Avogadro's number of atoms. So this is the mass of one atom. So they're asking why Avogadro's number. So Avogadro's number of atoms will be taken first, and then you plug in this ratio and you will get the answer as, okay, Amodita is saying 15.96. So I think that is more accurate because four significant figures, Akash, four significant figures, right? So more accurate number is 15.96 grams. Mayank, you're not answering anything. I hope you're understanding. Okay, good. The one on the top. Oh, okay. This one. Hmm. So who is right? I think I have not read the question carefully, so that's why I was just not paying attention much. So now let's see the question again. This is something which is given to us. This is given, and this is defined number. So who is right, Akash or Amodita? Akash is right because you are going to decide sigfig from the number given, the measured value, not from the defined value. So when you put this number into two significant figures, you have to drop this 96. When you drop this 96, it will become 16 gram. And there is no need of decimal. If you put the decimal, okay. If you don't put the decimal, still okay. Amodita and Mayank, we are doing correction here because this is something which is given to us, right? And we are calculating the mass of 1 mole of atoms. It's a defined number. Okay. Now let's do the another question. Now we have understood the meaning of the mole. Mole means Avogadro's number of particles, atoms, molecules, anything. Anything with this Avogadro's number is a mole. Now, when I give you 1 mole, I have now question. I'm just asking question because we have understood this concept very well. So when I give you 1 mole of P or 1 mole of Cl, 1 mole of iodine, they all are 1 mole. So do you think they will have the same number of atoms? But do you think they have the same masses? So remember this. This can be a question. Their atoms are number of atoms are same, but their masses will be different because each atom has different atomic mass. Very good. So mole means the numbers are same, but masses will be different. Here, this is the example where you can see uh, even in appearance, the quantity will be different. Like here, this is 1 mole of carbon. Its mass is only this much. This is 1 mole of iron. Mass is this much. This is 1 mole of copper. Mass is this much. This is 1 mole of sulfur. Mass is this. So what is same in all of them? That number of atoms in every petri dish is going to be this Avogadro's number, but their masses will be different. Okay. Now, how to convert a mole to a number? So I'm taking you out of this presentation and I'm going on the one of the best book. I have already shared the book there on the website also. So I'm just taking out questions from that book. And we are going to do questions based on mole concept. Yes, Zumdan. I'm just sharing questions from that book. So the concept which we have learned, we are going to do question based on that. Okay. Here are the questions based on moles and molar masses. So what is the molar mass? That you can calculate by looking at the periodic table. So let's start with this question. Question 45. Calculate the mass of 500 atoms of iron. So what is given to me is 500 atoms. Just take care of the significant figures. How many sig figures are there in these 500 atoms? How many sig fig? You can see there is a decimal. There is a decimal. Decimal. Yes. Atoms of Fe. Start with this. Convert these atoms of Fe to moles of Fe and convert that moles of Fe to grams of Fe. This you can use the periodic table. You already know that 1 mole of Fe is Avogadro's number, and that is, what's the atomic mass of Fe? Something like 55 point. How much? Atomic mass of Fe from the periodic table, 845 gram. Plug in the ratio, dimensional. Okay, in the free response question paper, they will ask you to show the work. And AP is very much into dimensional kind of mathematics. So, and take care that your answer should be in 3 sig fig. One mole in the numerator. Everyone is comfortable with the dimensional. And when you are doing the free response questions, you're going to plug in the units very carefully. Multiplied by the next dimensional is of the grams. 55.845 gram divided by 1 mole of Fe. And then you check that these moles, the units which you don't want, they are cancelling out. Amodita, answer will be very small because Avogadro's number is in the denominator. So that's the reason I'm asking you to take care that you write everything properly because you are in the learning stage. So don't try to use shortcuts. Mayank, write everything step by step the way I'm asking you to do. Because this is the learning stage, and in learning stage we have to be very particular with all the steps. After that you can use tricks. But first you have to master the subject in a right manner. So generally I don't give tricks in the starting. So when we are learning something new, we have to learn in depth, slowly, step by step. And then later on, when you have practiced many problems, then your brain will direct you in the direction of tricks. So are we okay with the answer given by Mayank? Akash. He said the answer is, I'm just typing the answer here, writing the answer here, which Akash has given. Is it correct? Mayank, you have your calculator with you? So Mayank, calculator is permitted. So we are not practicing here calculations. It's not a mathematics class. So feel free to use your calculator. I did not know what. You could not get this answer, Mayank? Oh, it is permitted. It is permitted in Chemistry Olympiad and in AP Chemistry. So we are not practicing mathematics here, right? Because if you start doing calculation without calculator, it will take too much of time. So children, calculator is permitted. Graphing calculators are permitted. I think I told you in the very first class. If you don't have graphing calculators, then please get your graphing calculators. Start using them, because I have seen children, they just don't know how to use graphing calculator. Okay, now ready for next? 47. Now, okay, Akash, you also slow down. You have to tell me first the method. Means what's the planning? What is given here? What is given? So read the question. 1.00 carat, that is given, right? From the carat, we are going to go to grams. From grams, we are going to go to moles. From moles, we are going to go to the number of atoms, right? By using Avogadro's number. And that's what they are asking. This is called as planning. So in every question, we'll do the planning. And then you can plug in the dimensionals. Okay, so start with what is given. 1.00 carat. Tell me the next ratio. The next ratio and the next ratio. And your sig fix will be decided by this number, the number which is given to you. Yes. What is the next ratio? Read the question. This is the next ratio, right? This one. So you're going to take 0.200 gram in the numerator over 1.00 carat. Significant figures will be from what is given. This is given. This is the ratio. Don't decide from ratio. This is given. So you will decide from here. It's 3. Very first digit, very first measurement. You're going to decide sig fig from here. Okay. What is the next ratio? Grams to moles. That 1 mole of carbon is 12.00 grams of carbon. Yes, very good. What is the next ratio? That Avogadro's number 6.022 times 10 raised to power 23 atoms of carbon over 1 mole of carbon. Now, just for practice, just ensure that all units are cancelling out, and you should be left with only number of atoms of carbon. Units cancelling out? Yes. And I'm left with only units of the desired unit. So answer, Akash is giving me the answer 1.00 times 10 raised to power 22 atoms of carbon. Mayank, where is your answer? Okay, are you using calculator? Check, are you getting this answer? So that is the reason calculator is not something which is always going to give you right answer. Some children, they just don't know how to plug in values in the calculator. So to practice the calculator, after cancelling the units, put all the numbers in the numerator. 1.00 times 0.200 times 1 times 6.022 times 10 raised to power 23. These are the numbers in the numerator. In the denominator, put parenthesis. In your calculator, you're going to put parenthesis. 1.00 times 12.00 times 1 close parenthesis. So it's only 12. Now plug in your calculator and check whether you are getting the answer. So Mayank, write down the answer of this question and you can check mathematics later on. Is it okay? Okay. So that's about how to convert moles, grams, number, how to calculate the molar masses. The molar masses, like for example, 51, look at this structure. Can you give me the formula of this molecule? Formula of this molecule, NH3. So in NH3, how many nitrogen atom is there? Nitrogen, just look at the periodic table, 14.01. Hydrogen, 3 times 1.01, and I think, and give the correct units, 17.04 grams per mole. So there is 1 nitrogen and 3 hydrogen. Let's calculate the molar mass of this molecule. This is a ionic compound. Can you name it? Name this compound. You know the name of this molecule? This is a covalent molecule. Do you know the name? Ammonia. Yes, Mayank. Very good. Can you name this compound? Look into your polyatomic ion list. This is, check nitrogen atom, polyatomic ions of nitrogen atom. What's the name of this? What's the name of this? This you can see in the last, chromate and dichromates. Yes, this is ammonium and this is dichromate. So what's the name? Oh, no, diammonium. It's an ionic compound, Mayank. Ionic compounds, in ionic compounds, we don't use di-tri-tetra. Amodita is ammonium. Check the name of this ion. It's ammonium dichromate. Do you have the polyatomic ion list? So can you see there? Where is the dichromate? Okay, I'm showing you the polyatomic ion list. Do we have dichromate? Yeah, here. See, this was there. So can you work out the molar mass of ammonium dichromate? So to work out the molar mass, follow the systematic method. How many nitrogens are here? 2 nitrogens. How many hydrogens? 8 hydrogens. How many chromiums? 2 chromiums. How many oxygen? 7 oxygen. And then look into the periodic table, plug in the values and get the answer. So Mayank is saying, Akash is saying 252.08 and write the units grams per mole. Is he right? Are you clear that why I have this 8 hydrogens? Because 4 times 2 is 8. These numbers, they get multiplied. This is in parentheses. There are 2 ammoniums. So that's the reason there are 2 nitrogens, 8 hydrogens, 2 chromium, 7 oxygen. So all of you are getting this answer? I think this is correct answer. Amodita? Okay, good. So that's how you have to work out the molar masses of the compounds and molecules. Ready for one more? This one, B. Calculate the molar mass of this compound. So can you tell me how many calciums are here? The way I I don't want final answer, Akash. Yes, like this. 3 calcium. How many phosphorus? How many phosphorus? Yes. And how many oxygens? 8. That's how you have to work out the molar masses. Yes, Akash, very good. Then you can use the periodic table. Yes, and then just add up. So that's how we are working out the molar masses. Now I'm giving you in a different direction, slightly more complicated questions. You have understood all these things very well. Okay. Okay, very good, Akash. You are doing very calculations very fast. Children, this is needed. If you become very fast in calculation, because calculator, using calculator means save time. In the examination, there will be 60 questions, and you have to do those 60 questions in 90 minutes, 90. So how much time you are getting per question in the multiple choice? Is permitted in MCQs also. Nearly 1.5 minutes. So that is the reason they have given permission to use calculator. Amudita and Mayank, you are understanding this? So start using your calculator, practice your calculator, plug in the values very fast. Okay, Mayank? And if you don't have graphing calculator, purchase a graphing calculator. Yes, Akash, very good. Akash is saying that because the numbers are too big, so it will be waste of time doing calculation without calculator because most of the time you'll be wrong. In these type of questions, significant figures are decided by the actually molar masses are maximum up to 4 significant figures. So significant figure is not important here. Like you see, Amodita has given us 6 perfectly correct answers. So here, no one is going to ask you put the number in correct significant figures, but minimum 4. The answer should be minimum in 4. Okay, we are doing this question. And please follow this systematic method. What number of atoms of nitrogen are present in 5 grams of the following compound? Let's do A part. So the mass is given 5.00 gram. Okay. Mayank is asking for the periodic table. Just give me 1 second. Mayank, you take a printout of this periodic table. This is one of the best periodic table. And you can use, like this is very popular periodic table. Even teachers are using it. So I'm giving it to all of you. Here, the molar mass is in 4 significant figures. Okay. So now let's do the planning. Read the question carefully. What is given? 5.00 grams of glycine. I'm writing glycine as GLY. From grams of glycine, where are you going to go? You will go to the, always remember grams to moles. You'll go for moles of glycine. From moles of glycine, where are you going to go? You will go for moles of nitrogen. And from moles of nitrogen, you can go to number of nitrogen atoms. That's the planning. Okay. Akash has already given the answer with very good language. Akash, perfect. Okay, so let's start. So 5.00 grams of glycine. Then you plug in the first ratio, that 1 mole of glycine divided by the molar mass of glycine. Molar mass of glycine you can calculate from here. There are 2 carbons, 5 hydrogens, 2 oxygens, and 1 nitrogen. So plug in that value here. And I think Akash is giving us the calculation. He's saying the molar mass is 199.63 grams multiplied by, now this is called as mole to mole ratio. So I will be calling it as molar ratio. We are going to use this mole to mole ratio in balanced equation also. So mole to mole ratio, what is the ratio here? In 1 mole of glycine, how many moles of nitrogen are there? 1:1, yes. So you write down 1 mole of nitrogen. What do you want? Will go in the numerator over 1 mole of glycine. And then what ratio should I take here? Mole of nitrogen to number of atoms. I'm going to take Avogadro's number, atoms of nitrogen, over 1 mole of nitrogen. And then you solve it. And how many significant figures, Akash? Akash has already given the answer. But don't worry, children. Akash, you are doing very fast, but I have to take care of the other 2 students also here. Akash, are you doing chemistry for the first time? Okay, how come you are so fast? That's really good. I'm very happy. Okay, okay, that's really good. See, perfect. Uh, Mayank, Akash has a bag, so he's very good in dimensional. He knows how to plug in the values, how to use the relations. Perfect. Mayank, you have understood this? Get the answer in 3 significant figures. This number has 3. Are you getting this answer, children? And take care of the units. Units are very important. In the examination, if you don't write down the units, you will lose marks. Okay, now we are going. How did you get the number for the molar mass? Formula is given here. I explained here. See, Amodita? This is the formula of the glycine. There are 2 carbon, 5 hydrogen. Are you not getting the same answer? 2 times 12.01, 5 times 1.01, 2 times 16.00, 1 time 14 point, I think, 01, something like that. Oh, okay. Yeah. So this is not the molar mass, right? So the molar mass is, yeah, when you do this mathematics, you will get, I took the molar mass given by Akash. So Akash, you gave me the wrong molar mass, right? Part E. Yeah, we are doing part E. I was doing this part only. Which part you were talking about? Oh, no. No, no. You are writing glycine. Glycine is in part A. So it is. So I think this answer is wrong then. So 75.08 grams per mole. Plug in this here. Akash, we are doing part A, okay? We are not doing part B. You have given the molar mass. This is your 75.03. Now what's the answer? 4.01 times 10 raised to power 22. Children, I'm not doing calculation, so please give me the correct answers. Atoms of nitrogen. Mayank, are you getting this answer? Good. Akash, no problem. Let's do the next one. In the next question, the formula is not given. So first, you read the name and give me the formula. Take out your periodic tables. Read the name and give the formula. What's the charge on magnesium? Magnesium is group number 2. What's the charge on nitrogen? It's nitride. It's not a polyatomic ion. Okay, Amodita, check what you are writing. What do you want to say? This should be 3. This should be 2. This will become plus 6. This will become minus 6. Amodita. So it is Mg3N2. Then it is 3 times magnesium plus 2 times nitrogen. So what's the molar mass? Mayank, you're getting this answer? Okay, this time Akash is giving us the complete systematic method and the units will be 100.95. Check this answer, children. Is it correct? Mayank, is this answer correct? And then give me the planning. Planning for the B part. I'll go from 5.00 grams of Mg3N2 to grams to, yes, there is only one thing you can do. You can go from grams to moles. So you will go for moles of Mg3N2 and then you'll go to moles of nitrogen and then you will go to number of nitrogen atom. I want you to understand this planning. Please understand this planning. A systematic thinking is really, really very helpful in every subject. It can help you in solving even very tough questions. So Mayank, you have understood this planning? And don't calculate for every step. Do the dimensional, Akash. We are not going to calculate for every step. 500 grams of Mg3N2. Plug in the first ratio. From here to here, plug in the molar ratio, mole to mole. Plug in Avogadro's number. Amodita is giving us the final answer. Akash, just check her answer. By the time I'm plugging the ratios. Then the ratio is 2 moles of nitrogen. Because in 1 mole of Mg3N2, there are 2 moles of nitrogen. Mg3N2. Then Avogadro's number. Atoms of nitrogen over 1 mole of nitrogen. Mayank, you're with us? And then plug in everything, like all the numbers, units cancel, check the units, are they canceling? All these steps are very important. And now, so don't be in hurry of posting answer here. Just see that, am I using all my steps? Am I understanding everything? Going in a correct manner? Once everything settled down in correct systematic manner in your head, then you can go very fast. But if you're doing error here, if you're not using a systematic method, your thinking is not systematic, then there are chances of errors, always. And these numbers are here in the denominator, times 1 times 1. And then you are getting the right unit, atoms of nitrogen. And now Amodita and Akash are giving me the answer, 5.97 times 10 raised to power 22 atoms of nitrogen. Akash, you're okay? Okay, Mayank. Mayank, where are you? Mayank, are you getting this answer? Yeah, okay, good. Are you getting this answer? This answer. The answer given by Amodita. Are you getting it? Okay, good. So keep confirming here so that I can move on with different questions. Now let's complete this table. Ready? Again, I want you to think systematically. 68, question 68. So what is given? A part. We are doing this part. And give me the planning. You're not going to give me the answers. You are going to give me the planning. How to go from grams of this to this. So grams of C6H6, you will go, yes, very good. You will go to moles of C6H6. Then you will go to molecules of C6H6. Molecules of C6H6 by using Avogadro's number. This by using molar mass, the way Akash is saying. Then from molecules of C6H6, you're going to go for total atoms of. Now, on every step, like you stop here, plug in here, then you stop here, plug in here, and then you stop here, plug in here. Okay, ready? So let's start. 4.24 grams of C6H6. Give me the first ratio. And give the answer also in 3 significant figures. What's the molar mass of C6H6? Okay, very good. 78.114 grams. Use your calculator and put the answer here. 3 significant figures, children. Because this number has 3 sigfig. We are getting 0.0543. Okay. These are moles. Okay. Now let's do the second ratio. Moles to molecules. I'm going to use Avogadro's number. So 6.022 times 10 raised to power 23 molecules of C6H6 divided by 1 mole of C6H6. Units cancelled. Can you see that how slowly I'm going? Because I feel that it's very important that you must learn everything in systematic manner initially. It's not only for this subject, for every subject. When you're learning, learn everything step by step with clear understanding. Don't worry about the tricks. Tricks will come on their own later on. What's the answer? Okay, 3 significant figures. Now, can you tell me the ratio for the next part? This ratio. Yes, very good. So in one molecule, I'm going to take this ratio. In one molecule of C6H6, there are 6 plus 6, 12 atoms. 12 atoms. I'm going to take this ratio, 1:12. That's what Akash is saying and Amodita is trying to tell us. Okay, so let's plug in that ratio. 12 atoms here and one molecule of C6H6 cancelled. And what's the final answer? The final answer is, okay, 3.92 times 10 raised to the power 23. Mayank, are you getting the answers? Okay. Okay, now we are going to do the next question. This part. So you're going to set up the ratio. Okay. So don't try to give me the final answer. Give me the ratio. So first thing is the number of atoms are given. Total atoms are given. So 3.35 times 10 raised to the power 22 atoms. These are atoms. So how to convert this into molecules? Yeah, so how to convert this into the molecules of CH3COH? You're going to use the ratio that one molecule of CH3OH is, yes, very good, Mayank. Very good, everyone. 7. Is it 7 or 6? 6. 6 atoms of CH3OH. Okay, now this will give you this answer. And the answer will have only 3 significant figures. After getting this answer, I want to know the moles. What should I plug in? Get this answer, children. And then I have to plug in the other ratio to know the moles. Yes, 1 mole of CH3OH is Avogadro's number of molecules of CH3OH. Molecules cancelled. And plug in the answer here. Take care of the units. Now I want to go to the grams. So what should I plug in? Now we need the molar mass. 1 mole of CH3OH. Should I take it in the numerator or denominator? It should be in the denominator. So what's the molar mass? 1 mole of CH3OH, and in the numerator? Yes, 32.022 grams. And then this mole and mole cancelled, and you'll get your answer here. Okay. Mayank, you're understanding, you're getting any answer? Okay, good. Okay, now this is the concept of your mole concept 1.1. Now I'm taking you on the next concept. We are starting the next 1.2. Sharing it with you. This unit is very important for your AP exam, any chemistry exam, okay, for chemistry Olympiad. This unit is based on mass spectroscopy. Spectroscopy is a technique. You're going to learn different types of spectroscopy, IR, infrared, NMR. In brief, very brief. This is the only one which is in detail. Mass means you're going to measure the masses of the different isotopes of elements. You are aware of the word isotopes? So we are going to learn about isotopes. We are going to learn about mass spectrometer. We are going to learn how to calculate the average atomic masses. You already know the meaning of average, right? Okay, so let's start with isotopes. If you look at the periodic table, I'm taking you on the periodic table. In the periodic table, oh, okay. Can you hear me now? Oh, okay. Sorry. I think this problem was from my side. Okay. So I was sharing the periodic table and I was talking about the average atomic masses. You heard that? Can you see this hydrogen? What is the atomic mass of hydrogen? 1.01 grams. This is average of different isotopes of hydrogen. There are 3 isotopes of hydrogen. You need not to memorize the isotopes, okay? They will give you the information. There are 3 isotopes. 1, 1. This is how we represent the symbol, right? 1, 2, 1, 3. Can you tell me why these isotopes have the same symbol? You can see it is H here, H here, H here. Why the isotopes have the same symbol? Symbol is same. Why? Because atomic number is same. The identity of the element is the nuclear charge. Yes. Okay, now the average means the mass of this hydrogen, first isotope, the second isotope, and the third isotope. You're going to add their atomic masses. You'll divide by the total number of atoms. Then you will get this answer. So when you look at this average atomic mass, can you tell me which isotope you are expecting is more abundant? Which isotope will be more in amount? Just see that average is closer to, yes, the first one. And this first isotope has a very specific name. It is called as protium. Protium. And the second one is called as deuterium. And the third one is called as tritium. Tritium is very less in amount. So here I'm going to teach you that if you look at the average atomic mass, you can easily identify that which isotope is more abundant there. Okay, more abundant isotope is more stable. Whatever isotope is more abundant in nature, that isotope is actually more stable. So they are question based on it. Like for example, look at the chlorine. Chlorine has two isotopes. Chlorine 35, 17, chlorine 17, 37. So which isotope do you think is more abundant in the nature? Look at the atomic mass of chlorine, average atomic mass. The average atomic mass of chlorine is 35.45 gram. That's the average atomic mass. So which one is more abundant? This one. So which isotope is more stable? This chlorine 35 is more stable. Similarly, oxygen. Oxygen also has different isotopes. 8, 15, 8, 16, 8, 17, 8, 18. These are different isotopes of oxygen. So which isotope is very stable and very abundant? 16. And when the atomic masses which are mentioned here, they are the average of all these. How to calculate the average? They will give you the percentage abundance. Like let's say this 15 is 1%, this 16 is 99%. Oh, this can be taken as 0.1%. And then rest of the percentages are divided here. So what you are going to do, you will take this percent multiplied by its mass, this percent multiplied by this mass, and then similarly you're going to do here, and you add all of them and divide by 100. So this is what we are going to learn. Okay, so the atomic masses in the periodic table are average atomic masses. Now, how to know the number of isotopes for a given element? Like I said, for hydrogen there are 3. So how to calculate the average atomic masses? You cannot see atoms, you cannot see their isotopes. So we have an instrument, we call it as mass spectrometer. In mass spectrometer, you are going to introduce your element here. Let's say X element. This element, this is the complete working of the mass spectrometer. Again, hardly any question will be there in AP exam, but in chemistry Olympiad, they may ask you some questions based on mass spectrometer. In AP exam also, some questions will be there, which is easy to understand. Yes, Akash, you're right. So in the mass spectrometer, you're going to introduce a sample here, like you're introducing an element. Then here in the first compartment, let's see the working. Working is very interesting. In the first compartment, which is called as ionization chamber. Can you see the first compartment? Ionization chamber, this one. So what is happening to the sample? Whatever sample you have introduced, what is happening to that sample? That sample is bombarded by the beam of electrons. Sample is bombarded by beam of electrons, and this results in ionization of the element. So that's why it is called as ionization chamber. Your element will get ionized like this, right? So this is ionization chamber. Now, after ionization, they become charged. Then there is a magnetic chamber. Sorry, not magnetic, acceleration chamber. Acceleration chamber, these are electric fields. These are two plates which are connected to a battery. So you are supplying electricity here. Now these charged particles, this plate has a negative charge, this plate has a positive charge. So the charged particles will move with great speed in the direction of the negatively charged plate. Now if I say I have two isotopes of this X 35, X 37. So in this acceleration chamber, which isotope will run faster? In this acceleration chamber, which isotope will run faster? 35 or 37? 35. Lighter particles, they move faster. So they will start separating here. They will start separating here. 37 will be behind 35. Then we have this magnetic field. You can see this magnetic field. This is magnetic field, magnet. Now, when these charged particles are passing through the magnetic field, they get deflected. Now, again, which particle will be deflected more? The lighter or heavy? The lighter. Lighter particles, they are deflected more. Then there is a detection screen. Here's detection. So they will go and they will collide with the detection screen. Detection screen is connected to a computer. Here is a computer. And this computer will reflect the reading in the form of graphs. So all the 35 particles, they are going here. They are going and striking here. 1, 2, 3, 4, 5 like this. Let's say you introduce 100 atoms of X, 100. And here these 35 particles, they are colliding and this computer is counting. And he said X 35 is 75, right? Then the remaining X37 is colliding here. Deflection is less. And let's say this is 25. Then it will show you a graph of the percent abundance, which is 75 and 25 in this case. Percent abundance. And here is your M over Z ratio, mass over Z. So what is Z here? Z is the charge. What is the charge on these? 1. So whatever M over Z ratio like this one, 35 is actually the mass because charge is 1. Amudita, you are with me? And you can see the ratio is like this. This is 37. So that's how this spectrometer is working. So let's see the working again. You're getting this graph. This graph is giving you the information, is giving you that what is the percent abundance, is telling you how many isotopes are there. So I'm going to show you different graphs. But before I leave this slide, let's try to just see the working of this spectrometer. Again, you're going to help me. So what are you doing here? You are introducing the sample in the form of gas. Samples should be in the form of gas. Even if you are using metal, you have to convert that into gaseous form. Then what is happening in the in your ionization chamber? You are heating. There is a heater you can see, and you're bombarding it with electron beam, and these atoms are getting ionized. Then what is happening in the acceleration chamber? Acceleration chamber. You're using an electric field. These ions have the positive charge, so there is a negative electric field which is created here. So ions are accelerated. They are moving with very big speed in the direction of this negative plate. So what happens here? The one which is lighter will move faster. So they start separating here. They start separating, lighter in ahead and heavier one behind it. So separation has started. Then you are using a magnetic field. In the magnetic field, because of the magnet and the charge, these are charged particles, magnetism and electric field, they deflect. So they are deflected from their path. They were supposed to go straight, right? They were supposed to go straight like this. But the magnetic field is deflecting them. So which one is more deflected? The lighter. And the heavier is less deflected, right? Then there is a detection screen. In the detection screen, all the lighter particles will go and collide here. The heavier particles will go and collide here. The detection screen is connected to the computer, which will give you the information of the percent abundance and the mass over charge ratio. Yes, Akash. Even if they are moving with, but you know that the kinetic energy depends on the mass. So what is the velocity? So velocity, they are not moving with the same velocity. Akash, so this line is wrong. They are not moving with the same velocity. You know that you said that lighter particles are moving faster because mass is in the denominator. This is the equation for the kinetic energy, children. And here, this is the mass, this is the velocity. So these particles are moving with different speed. They start separating here because of the different masses. And then they are deflected again by different angles. The one which is more massive, less deflected. The one which is less massive, more deflected. This can be a chemistry Olympiad question. Okay, good, Akash. Okay, so this is how the graph will come, the spectrum. We call it as spectrum. And this is mass spectrum. It's based on percentage abundance and the M over Z ratio. Z, you can write Z or E. That is mass over charge ratio. Generally, the charge is always +1. So can you look at this and can you tell me how many isotopes of neon are there? How many isotopes of neon are there? Okay, Mayank and Amodita, why there are 5? One is this 20. This is signal. These are called as signals. Second is this. And third is this. How come 5? Mayank and Amodita. So there are only 3 isotopes. Correct? So these signals, count the signals. If I give you some kind of spectrum like this, here is the percent abundance. Here is M over Z ratio. If I give you signals like this, can you tell me how many isotopes are there? How many isotopes? Yes, now it is 5. Which one is the, let's say this is A isotope, B, C, D, E. Which isotope is most stable? Which one is the most stable? And which one is the least stable? Least. We are working on this graph here, Amodita. E is the least stable because its abundance is minimum. Same here. Which isotope is the most stable in this graph? So the average atomic mass will be closer to Yeah, check in the periodic table. What's the atomic mass of neon? 20 point something, right? Average atomic mass of neon is, how much is this? Yeah, can you check the atomic mass of the neon? Yes, 20.18. Now, how to calculate the average atomic mass using this table, this information? So, you are going to take the mass 20. They will give you more accurate masses. Take a weighted average. Yes. So, 20 times, in the question, they will give you more accurate masses. 20 times percent abundance plus 21 times 0.26 plus 22 times 8.82 divided by 100, because you are assuming that there are 100 atoms. You are working with percent, so we assume that there are 100 atoms, and when you do like this, you will get the weighted average. Sorry, there was some internet problem. You can hear me, right? So I was telling you how to calculate the average atomic masses by using the percent abundance. You heard that? Okay, so let's do some questions based on it. So, so what information you can get from the mass spectrum? This can be a question. What information a mass spectrum is giving you? Is telling you the number of isotopes, the percent abundance of every isotope, and is also telling you the stability of the isotopes. The more abundant is more stable, and is also giving you the average atomic masses that you have to calculate, right? So this is the information which we are getting from the average from the mass spectrum. Okay, ready for this question? Read the question carefully. This is the formula which we are going to use, Mayank. Average atomic mass is the sum percent abundance times atomic mass of isotope divided by 100. Because if you are taking percentage, then it means the total atoms are 100. Okay. Can you tell me how many isotopes of this element are there? Can you just look at their percent abundance and can you tell me the average atomic mass will be closer to which value? Without calculation, it will closer to 48. Is it going to be higher than, slightly higher than 48? Why 47 is 47.94, right? Closer to this. Is it going to be higher than that or slightly lesser than that? The value will be higher than this or lesser than this? Slightly lesser. Yes, slightly lesser. Now, check your periodic table. Identify which element has its atomic mass closer to this value. Average atomic mass closer to this value. Yes, this element is titanium. Very good, Amodita. Very good. Titanium. Okay, this is how you can identify an element also. So you introduce element, unknown element into the mass spectrum. It will undergo all that process of splitting and everything, ionizing and then acceleration and then deflection, and then detection screen is going to give you the complete information in the form of a graph. And from there, you can calculate the average atomic mass and you can identify your element. Let's do more questions. Okay. How many isotopes? Answer first. 4. Which isotope is most abundant? Which one is more? So average atomic mass estimated is around, so 56. Yes, Akash, good. So element is iron. Very good. See, simple questions. So these type of simple questions will be there. If they are asking you to estimate, then don't calculate. But if they are asking you to calculate, then definitely you have to calculate it. Okay, this type of question. Here you know the element. If you know the element, you know the average atomic mass. So look at the periodic table. And can you tell me what is the average atomic mass of silicon? Average atomic mass of silicon. Yes? Okay. 28.09. Okay, let's take that. You can say U. See, they are using U. So can I use U here? Now you know the meaning of U, right? So I'm using U. So that's the average atomic mass. They have given the mass of this iso. There are three isotopes. You can see 28, 29, 30. They have given their accurate masses by using the accurate masses of the protons and neutrons. These are the masses. This I want to calculate. This also I want to calculate. Can you calculate the percent abundance? Can you calculate Y? Can you calculate Y here? The sum should be 100. Y plus 4.70 plus 3.09. So yes, 92.21%. That is why. Now what you are going to do? Simple mathematics. This mass multiplied by is. So this question we are going to solve completely. Multiplied by 92.21. X multiplied by 4.70 plus 29.97 multiplied by 3.09 divided by 100 is equal to 28 point, the average, this average from the periodic table, 28.09 U. All these are in U. And then you can calculate the value of X up to how many significant figures? Mhm. So here we are adding them, right? When you add addition, subtraction, the sig-fig rule is different. There you have to go for minimum decimal places. So every number has two decimal places. So final answer will have two decimal places. Final answer will be in two decimal places. So just check that how much you are getting. Can you just tell me what is the numerator? Okay, these two numbers, you add them. And I think once you are going to use all the calculation, finally you are dividing it by 4.70. So 4.70 has only three significant figures. So final answer will be in three significant figures. Okay, work out X. What is X? You calculated X? So I will teach you about sig-fig more once you do one quiz based on sig-fig. Watch the video, do the quiz, and then when I'm going to teach you, when I'm going to discuss, then you will understand better. Okay, Amodita is saying 29.1 and Akash is saying 29.0. What about you, Mayank? Mayank, you're calculating? Okay. Are you getting the same answer? 29.0, 29.1? Okay, take your time, Meg. So X is 29 point. I'm taking 29.1 U. So that is the answer. Okay, I have not done the calculation. That's fine. Perfectly all right, Akash. Okay, this is another type of question. Like here, you calculated the mass of one of the isotope. Moving on. Can we do this question? This is again the mass spectrum of an element. No, they are not six. It's an element. How come the isotopes? Isotopes, they don't differ by this much number. Okay, understand that. So how many isotopes? Three, not six, because they don't differ by this number. I said it's an element. Element can be X2. You know the diatomic gases, right? It can be X2. So look at this 16, 17, 18. Can you tell me which element is this? Which element is this? Yes, it is the mass spectrum of O2, O2 gas. So when you introduce this O2 gas in that ionization chamber where you are heating it and bombarding it with electron beam, it's going to split as O. So there are some atoms as O plus, but there are some of them as O2 plus. So you're getting signal for O plus, you're getting signal from O2 plus also, right? So these are the three isotopes. Can you tell me this signal is because of which isotopes? Can I say it is 16 and 16? 16 and 16, this one. What about this signal? This signal will be 16 and 17, 116, 117. What about this signal? 16 and 18. You can get more signals, but their percent abundance is very less, 17 and 18, they are less. So those signals will be very, very small. Yeah, it can be. It can be 17 and 18, but which one you are saying? 17 and 18? This is 32, this is 33, and this is 34. 17 and 18 is not 34, right? Yeah, it can be. But can you just think about that the percent is very less? So if the percent is very less, then the signal height will be very, very less, not this much. That's why I've taken all of them with 16. So because the signal heights are good, that's why I'm taking that. Most of them are with 16 only. Okay, good. Another question. Okay, may do it fast. Identify the element. Okay, that's good. It's boron. Why? Because the most important, the most abundant signal is of 10. So atomic mass will be slightly higher than 10, and that is boron. So these type of questions will be there in your exams. Chlorine atom. This I already asked you. Look at the periodic table. So which isotope is more abundant? 35 or 37? Yes. Okay. Can you see the ratio of their heights? This is 35 and this is 37. If this 35 is 75%, then this is 25%. This is a very unique nature of chlorine. Its isotopes are in the ratio of 3:1 in abundance. Chlorine 35 will be 3 times more than chlorine 37. 35 will be more than 3 times. This is fixed. Organic chemistry students are using it as an identification tool. Whenever you see signals which differ by unit 2, see this is 35, this is 37. When you see these signals in the ratio of 3:1, it means chlorine is there. So it's used for identification, right? Same is with bromine. Bromine is also very unique. In bromine, can you see this one? This is bromine atom and this is Br2, Br2. This double of this. So what is the abundance of these bromine atoms? There are 2 isotopes. You can see 2 isotopes. Bromine 79. What is the ratio of their abundance? 1:1, 81. So check this signal. This signal is due to bromine 79 with bromine 79. This signal 158. This is Br2. This is molecular signal 79. The second one, bromine 79 with bromine 81, and that is Br2 with atomic mass of 160. The third, Br81, Br81, and that will give you Br2. Because they are 50-50%, 1:1, so I can say 50% is your Br79. So if I say there are 100 atoms, then 50 atoms are Br79 and 50 atoms are Br81. Now the probability that this Br79 combining with another Br79, can I say it is now 25, right? And Br81 combining with Br81, 25 plus 25. But what is the probability of these two combining with each other? It's double. It's 50-50. It's double. The probability is double. That's why the ratio of the heights are like this. No one is going to ask this question, but that's how you can understand that why this 160 is double of 158 and 162. Right? I assume the total atoms 50. You are working with one atom, Akash. You're saying one atom of Br79, one atom of 81. I said 50 atoms of this, 50 atoms of this. That's how I'm working. Okay. So if there are 50 atoms of Br79, then if Br79 combining with Br79, then it means 25 combining with other 25. Same with other one. So my method was different. You are using one. So are you okay with the bromine? So how to identify bromine? I just want you to take away from here how to identify bromine, Mayank. From the mass spectrum, when you have two signals at 79 and 81, which are in the ratio of 1:1. This is very unique method of identification of bromine in the sample. Is it okay? Okay. So that's the end of your unit 1.2. I think class time is also over. So today we have done 1.1 and 1.2. Can you do the questions on the website? Is there anything which was troubling you, Mayank? You can stay back and you can talk to me. And if you have any questions, please stay back.